Okay, so let's start our lecture. So the question is, you have to find out the diameter of the pistons are shown, which are given here. So this diameter is d1 equals to 3 inches and d2 equals to 1.5 inch. Determine the pressure in the chamber 3. PSI means pounds per square inch absolute, where the other pressures are given 150 psia and P2 equals to 250 psia. Remember, the pressure equals to force per unit area. Now guys, what is force per the area? Area is area of a round shape. How much is that area? So if we consider that area of a round shape, so let's consider starting from 1, let's consider that means force equals to pressure times area. So yeah, Charles is correct. Pi by 4 DC. That's good. So look over here. I'm gonna find out the force F1 and force F2, because we have to find out force F3 because this is not given directly. But we are lucky that the pressure P1 and P2 are given, and we can find out the force. So how can you find out? So pressure P1 equals to 150. Look over here, it is 150. So I'm gonna write down 150 times area is pi by 4 d1 square. So now what is the diameter? 1. That is equal to 3 inches. Now if we do the math here, so let me show you. If you do the math here, so 150 times pi by 4 times 3 square. I got 1060.3 pound force. The force is in pounds because British system is foot pound second system. So pound sub F means pound force. Sometimes it is sub M, which is pound mass. So you should not get confused with the unit. If it is pound F, then you should consider this as a force unit. Okay, guys. So now let's do the force. Find out the force F2 using the same method. F2 equals to pressure 2 equals to 250 psia. So how are we going to find out the pressure to force F2? So look over here, I'm going to write down 250 psia. Area of this um, above this like the circular area of this top of the piston, which is 1 inch, 1.5 inches. So I'm going to write down 1.5 square. And now I'm gonna show you multiplication times pi by 4 times 1.5 square. This is what I'm getting. 441 point. Let's assume this is 441.8. Round it off by tenth of the mm, decimal place. So this is my F sub 2. Now we are good. So we have to take the same free body diagram. I like free body diagrams. So when you see such questions, it is good that you show me the forces in terms of arrows. So F3, and what is F1? It is 160.3. 3 1060, sorry, 1060 this is 1060.3 minus. Now guys, this is the force exerting in this chamber. This is the chamber, okay? And now this is quite messy figure, but I'm going to show you this figure again. This one is the pressure exerting on this chamber, so we want to find out the force in exerting on the top of this piston in chamber 3. That is my objective. That is so the question is find out the pressure, determine the pressure. After we find the force, we can find out the pressure. Pressure equals to force now guys. Look, area 3 is, if you take a look, this is my area 1, this is my area 2. So can you find out area 3 by subtracting area 1, sorry, subtracting area 2 from area 1, because you will get the remaining area if you subtract this area. Do you understand this concept? Please type in yes if you understood this hollow the chamber area. Charles, Andrew, Alan, Harold. That's good. That's good. You guys are understanding the concept. So areas. Let's do the area 3. Area 3 equals to A1 minus A2. So what is my A1 minus A2? And if you do it at home, you should be able to get this is about 5.302. To save time, I'm not going to solve each and every calculation. Is this okay with you? Please type in yes if I skip some of the subtraction or calculations to save time. That's good. Charles, Alex, Eduardo. That's good. Okay, thank you guys. Now look that the remaining portion is very easy. P3 equals to F3 is 618.5 pounds. And this is our 5.30. If you solve for this, you should get about 117 pounds per square inch absolute. Remember, absolute means like you are including, suppose this is like this is the P atmosphere and this is P1. So P1 plus P atmosphere is at the bottom, which is in, when you add the atmospheric pressure into the gauge pressure, you get absolute pressure. So have you understood this question? Please type in yes if you understood this question. Charles, Herbie, Andrew, Alex, Micah. That's good. Very good. So now we have done which question? 1 dash 58.3. Sorry, 58.8e. And I assure you, if you understood this problem, let me show you the next problem. 59. Let's go over to the problem number 59. I want to show you that 59 is same as that of 58e. It is using the same figure. Look, the same figure. So I think you should be able to solve this problem since the method is same. So when you go home, you try to solve this question on your own. Will you try? Okay, let's do the question number 69. Please draw this diagram. Both gauge and manometer are attached to the gas tank to measure its pressure. So make sure you understand the concept. This is the gauge attached with the tank, and the gas is exerting pressure inside the gauge, and the gauge tells us the gadget showing the where is it, like suppose this is 80 kilopascal. This is the gauge pressure, and this is also hooked up with a manometer, which is like a U-shaped tube, and it has some liquid, like it starts from here, and then the pressure difference that I talked about it last time, that this is the head, and you remember pressure equals to the difference of the head in the two columns. That is the difference. This is the pressure head. So I'm always concerned about the difference in the two columns. This is the head, which actually tells me the pressure, the formula. So the question is, determine the distance between the two fluids levels of the manometer. If the fluid, determine the distance between the two fluids levels. So you have to find out this H, distance between the two fluid levels, and if the fluid is mercury. Mercury is this one. And you know the density, you need the density of mercury. For the density of mercury, it should be in your formula sheet. The 13,600 kilogram per meter cubed. And the density of water. Suppose if this liquid, the first case, this is mercury. What is the height or the head difference when it is mercury? And the second case, when you replace it by water, what is the head? And it is obvious in mercury will have a lower value of H as compared to for water. You will see that because mercury is very heavy, it is very difficult to lift the mercury up in the tube. But if you replace mercury by water, this will go very high, and it is very easy for this gas to put pressure inside this end of the tube, and then this is the middle, and then it will lift the, you see my point? So let's compare the density of mercury is given, the density of water is also given. So let's focus on the first part. What is the height in the column, the difference in height when you use mercury as the manometer liquid? So we know that pressure equals to rho gh, h equals to pressure over rho g, 80, I would say 80,000 kilopascal is the cause of that. Rho is 13,600. Gravity is 9.8. Can you open your calculators and help your professor? Please write it down. Any student who Point 0.6. Eh, Charles says point 0.6. Anyone else who agrees with this answer? Herbie says yes. Alex says yes. That's good. That's good. Very good, guys. So you guys are learning very fast. You are a fast learner. So let's find out what is the head when you replace this manometer liquid by water. So H equals to rho pressure over rho G. Pressure is 80,000 Pascal and rho is 1,000. Now open your calculators and solve this height. Charles says 8.14. I'm very happy with this student that he's very much like engaged. So I'm good. Anyone else who can confirm this? Jared said yes. That's good. Jared, you are also right. Alan says yup. That's good. Yup, you are right. Anyone else who agrees with this solution? So you see, guys, you see that Alex says yes. We have now. Let me tell you that you have you have done this work, and this is very high. The water column is about 8 meters higher than this, about 8 meters. That's right. So it is usually convenient depending upon what type of pressure you are measuring. If it is in this range and you have a small manometer tube, like less than a meter, it is better to use a thicker fluid to design. So please type in yes or no in your chat box if you understood this. Herbie, can you ask the question?
Hey, sorry, I'm just confused why we wouldn't factor in like atmospheric pressure on the part of the pipe that's like open on the right side.
Because that's a gauge pressure. That's a good question. Look, the gauge pressure is the gauge pressure is you you, you will subtract the absolute pressure from the gauge pressure. So if suppose, let me tell you the gauge, but let me write it down again. Suppose if you have pressure P1 in this tank, okay, pressure P1. So gauge pressure would be pressure P1 minus P atmosphere. You understand that?
Yeah.
So they have actually written by skipping some steps that actually this is the pressure inside the tank, and the gauge pressure is the difference of the atmospheric pressure and the pressure inside the tank. So that's a gauge pressure. That was a good question. And when you see the gauge pressure, it is already taken care of the atmospheric pressure by taking the difference. You understand me?
Yeah, thank you.
Oh, you're welcome. Uh, you can write down in the chat box. Sometime I'm not able to see the hand raised. Let's do the next question from the what we call the chapter. I want to solve one more question here for you guys. Let's solve one question number 73. That's 72. So let's add one more question here. 72. So a mercury manometer. This is a mercury manometer. Of course, this is a mercury. Okay, you find out the difference in the height, which is 15 millimeter. It's very small, so it's not very large pressure head. So the question is, the mercury manometer is connected with an air duct to measure the pressure inside. So the air is flowing inside this duct. Okay, like if you have the HVAC system and you want to find out the pressure of this HVAC system using the manometer, the difference in the manometer is a level. So let's write down the difference, and it is always good to convert it into meters. And now the question, the difference in the manometer is 15 millimeter, and the atmospheric pressure, which is on exerting on this end, it is 100 kilopascal, which is a standard. Standard is 1 kilopascal. Sorry, 100 kilopascal. So 100 kilopascal or 1 bar. Pressure atmosphere is also known as 1 bar, and that is equal to. I'm sorry, this is not 1 bar. Let me tell you that it is 1 bar. Yes, sorry. 1 bar equals to 10 to the 5 pascal. These are some conversions you should know. And now the question, judging from figure, determine the pressure in the duct above or below the atmospheric pressure. Determine the absolute pressure in the duct. So you will see. So this is a positive. So pressure in the duct above the atmospheric pressure. This is above because this is uh, lowering. This tube is pushing it downward. So it is, this pressure is higher inside the air. The duct is higher. And what is the pressure? P over here. So how am I going to start? Let us start from here. P equals to what? The difference. Let me do it this way. Let me do it this way. If you start from here, P atmosphere plus this head, rho gh, going down from P atmosphere plus rho gh equals to this pressure inside this. So that's what it is. So atmospheric pressure is 100 kilopascal, or you can convert it into pascal. Rho for mercury is 13,600, 9.8.015. That will give you the pressure inside this duct, which is about 102 kilopascal. Please type in yes if you understood this problem. Jared, Charles, Andrew, Herbie. That's good. That's very good. Let's do some more problems here. Let's focus some of the problem from 80 to 84. You can add one more problem here. I forgot some of the problem I'm missing, which are also very important. 78, 79, 80, 81, 82, 83, 84. I'm going to solve problem number 79. Is it okay if I solve some homework problems here? Or 78? It gives me a feeling that I explained the material. Matthew, you have a question?
No, I was just saying I'm fine with you doing homework problems.
Okay, that's good. Okay, let's go one problem here. Fresh water. This is a very good problem. I want to show you a very good problem. Please draw this diagram. The question is fresh water and seawater flowing in parallel. Like these are the tubes. Okay, these are very big. I'm not sure big or small, whatever. So these are the tubes. So you have attached a manometer. It could be a chain of tubes, like this chain. So it is not necessary. This is just a U tube. It could be like this U tube. Then it is connected to another pipe. So you want to find out the difference between pressure, tube pressure. So let's do this. Assume this is my pressure one, fresh water, pressure two, seawater. The question is a double U shape, a U tube manometer. Determine the pressure difference. So you have to find out the delta P. Let's use this P1 minus P2. Take the density of seawater. Seawater, I will say SW equals to 1000, which is denser than the fresh water because of its salty like uh, nature. Can the air column be ignored in the analysis? We will figure it out. So let's do this. So I'm gonna show you. You remember I showed you this question last time. I explained this question. You start from here and going down, you add the pressure. Going up, you subtract the pressure. So I'm gonna teach you again this technique. So look at here. So I'm gonna show you this starting from the left column. P1 is the pressure here. It's going down, and this is whole P1. Okay, this is all P1, and then comes 1 second. I'm sorry, this is pressure P1 over here, and this is my rho WGHW, and this is my air column, air GH air. The difference is this one. I'm sorry, this is not air. Why am I showing? Guys, this is mercury. This is mercury. Is the difference is 10 centimeter. So mercury, mercury, and the air column is the difference. Look at this. This is the head. So this is 70 centimeter minus rho air, GH air, and then the over there you have to add seawater. Seawater is you have to add rho SW HSW equals to P2. That's what I got, and that was a lengthy, but you have to consider this is the a lot of double tube manometer. You have a lot of liquids combinations, but you should know how to find out the difference P1 minus P2 if you rearrange everything here. So this goes to the right hand side. Rho, I will say, let me write it down with a negative sign here. Rho WHW, rho HG, HG, HA, seawater. Okay, guys, so now we have done this work. So let's find out density of water. Fresh water is 1000. Density of fresh water is 1000. Height, the depth of water is 0.6. By the way, look at here. Look at here that the gravity can be taken out from this as a distributive property. So let me do this over here. I can write down negative. I want to save my time by taking the gravity outside the parenthesis. Minus 1000 is the Density of fresh water, head is 0.6, and then rho is of mercury is 13,600 times Hg, which is zero point 0.1, and then air is, the density of air is 1 kilogram per meter cube, so 1 times 0.7 for air minus rho of sea water, which is 1035. I'm sorry, this is 1035 times the head is down, which is zero point 0.4. If you do the math, what do you guys get for this one? In my notes, it is about, or let's do this together. I want to show it. Maybe you can confirm your answer. So 9.8 times 600 plus 1360 plus 0.7 minus 1035 times 0.4. I got about 3397.66 pascals. So if I want to find out, this is in Pascal, guys, this is in pascals. If you want to convert the delta P in kilopascal, divide by 1000, which is 3. Oh, let's do this like the kilopascal, approximately. Do you understand this question? Jared, Alex, Charles, that's good. Eduardo, Herbie, that's good, very good. Matthew, Micah. Okay, guys, very good. So now look, I'm trying to cover as many problems as I can so that you should have good grades in this class. Okay, let's do one problem here. So one more problem. Problem number 80. I think I should upload this lecture on YouTube. Do you agree? Okay, I'll upload it on the YouTube so that you can easily see this in later time. It's good for our quiz and test preparation. Calculate the absolute pressure P1. Please draw this diagram. You have to find out the absolute pressure. So this is the pressure exerting on this fluid A. Specific weight is given. Make sure that you understand the concept P equals to rho GH, where rho G is also known as another term, specific weight. And when you specify weight like Newton per meter cubed, like for example, rho, density of rho is kilogram per meter cubed, and the unit of this gravity is meters per second square. So kilogram meter per second square is what? Can you type in your chat box what is the derived unit named kilogram meter per second square? This is equal to Newton. Good. Newton divided by meter. So when you specify newtons per unit volume, newtons per unit volume, it is known as the specific. You are specifying. So the term rho g, sometimes there it is written like this letter gamma. So you should not be confused. Oh, the what is gamma? Gamma is specific weight. Okay, let me show you. The pressure is being exerted over here on this column, which has a specific weight of 10. So rho of fluid A is 10 kilonewton per meter cubed, and then it has another fluid B. The specific weight of fluid B is 8,000 newton, or 8 kilo newton per meter cubed. So what you have to find out, the local atmospheric pressure is given. So local atmosphere, so calculate the absolute pressure P1. So let me do the chain of the pressure starting from here. Okay, starting from P1 equals to this column. Can you guys tell me? It should be negative, right? Negative HA, and then it's going up. Negative, and then plus P atmosphere. Because both are the column, starting from here, you see, going up. You see this is going, everything is going up, so it's negative. So if I want to find out the local atmospheric, is the manometer P1, we have to find out the, 1 second. Let us start from the other side. Can you give me 1 second? I want to start it from the other side. Let's start from here. So P atmosphere, the difference in the pressure head is how much? 0.5, 0.15. It is positive, correct? And then going down, this is positive. Oh, you know, I did not do a mistake. I tell you what I did. The previous one was also correct. Let me go back. I'm not sure why did I. Look, the mistake what I did over here, while you're going down, let me show you the mistake over here. While look over here, I should not have put the negative sign. Going up from here, that was my mistake. You have to consider this equals to like this. I'm sorry, I forgot to put the equality sign later. It should come later. You understand the concept? I Have you understood the mistake where what I was doing there? You could have done this on the other side. So this is how you should have done this. So P1 equals to P atmosphere plus rho A H A plus rho B. This is not the rho, this is gamma. This is gamma. Gamma. I'm sorry, why am I not able to write down correctly? Now let's do this. What is S750? 58 millimeter. So it is in millimeter, like the barometric pressure. So you have to convert it into pascals. So I'm telling you that the 1 millimeter of mercury equals to 133 pascals, or 1 millimeter of mercury kilopascal. This is the unit conversion, and now you can convert atmospheric pressure, which is 758 millimeter of mercury, into kilopascals. So let's convert it into kilopascals. So 1 millimeter of mercury equals to, the right hand side is 0.33 kilopascals. And then you will plug it in over here. So let me plug it in, let me write it down here. 758 times 0.133. 100 kilopascals. And specific gravity, specific weight, sorry, specific weight. There is another word, specific gravity. I will talk about it later, or I have talked in the lecture previous. So specific weight times HA. So that is equal to, specific weight is how much? 10 kilonewton per meter cube. 10 kilonewton per meter cube. And the difference in height is 5 centimeter. So I can write down in meters, 0.05 meters. So if you solve for this, you should be able to 0.5 kilopascals. How? Look, kilonewton per meter square, per meter cube times meter, it becomes, this is pascal. You see my point? So then rho b, sorry, specific gamma b times hb. Gamma b is how much? 8 kilonewton per meter cube. 8 kilonewtons. And the height difference in the height is 15 centimeter. So I can write down 0.15. 1.2 kilopascals. So I've found all the units and everything. So let's add this up. Let's add this up. So P1 would be equals to 100.8 plus 0.5, 1.2. How much do you get for this one? So let's do this 0.5, 100.8 plus 1.5 plus. I got 102.5. So do you understand this question? Question is a high, so the height that you're factoring in each term is a high difference between. Yes, always high difference is the uh, out of balance pressure. That is due to the pressure, because you have to find out difference in the two U tubes. You see? Do you understand, Herbie? You have to always consider the difference in the columns. Okay, so we have done quite a lot today. That's good. So, but even then, if you have done this, you when you go home, practice. And I'll be happy if you solve all these questions um, before the test Sunday. Will you be able to solve all these questions before the quiz? Please type in yes. Jared says yes. Charles, yes. Andrew, yeah. I'll be happy that if you solve all these questions and this will be your practice. Practicing is very good for your exam. Okay, 87 problem. I believe I've solved this in my YouTube video lecture. Let me make sure that I've solved this on my YouTube video lecture, so that you should not be worried about. Some of the questions are repeating. Yeah. You see, I solved this question. Yeah. You want me to share with you? Look, when you go home, watch. I want to share with you the screen. So P for glycerine at A, either add or subtract. This is the same question which I was about to solve, and it has been solved in my YouTube lecture 2. So when you go home, please watch this lecture. This is about 5 minutes long. Glycerine, but you used mercury. So what should be the pressure head difference for mercury? So you understand, when you go home, can you watch this lecture? Please type in yes. Okay. So with that, I'm done with this today's lecture. So any question before we finish this meeting? Please type in yes if you are okay, and then I will finish the meeting. Yeah, I can hear you.
Would it be possible for you to keep the Saturday, which is
Ask me again.
would it be possible for you to keep the homework open till Saturday for the quiz?
Everyone who agrees with him, please type in yes. He wants me to open the quiz homework problem till Saturday.
I couldn't hear him.
Am I quiet?
Yeah.
Okay, I'll open it. Keep it open for Saturday. Okay, guys, people are saying yes, so I'm gonna open it. I'm gonna stop the video.
Thank you, Professor.
You're welcome. Bye bye.